Hello, everyone. A very warm morning, afternoon, and evening to dear authors and invited guests. I am Dr. Neha Tiwari, the host of your session from the team ICICT 2022. I welcome you all once again. On behalf of Global Knowledge Research Foundation, it's my great pleasure to welcome you all to the 7th International Congress on Information and Communication Technology through Zoom. Further, as you are well aware, we have been facing new normal situations while overcoming the pandemic. Hence, the conference has been shifted to a hybrid mode. We are very thankful to everyone present on this platform to go along with us digitally for the conference in these unpredictable circumstances post-COVID and making this conference more productive. We wish everyone and their families a protected time. We hope you all have enjoyed day one and will enjoy day two even more from the perspective of knowledge sharing and having an interactive digital session. There is a special note for the presenters. You will be given 10 to 12 minutes for the presentations and 3 minutes for question and answers. On 10 minutes, I'll raise a gentle reminder to you. I request while the presentation is going on, other participants kindly be muted. There is another request to all the participants that you all stay connected with us till the closing remarks. Just before we get started, I would like to introduce you all to the chair of this session, Professor Prashant Dhotre. Professor Prashant has more than 17 years of teaching and research experience. Currently, he's working as an associate professor in the Department of Information Technology of MIT School of Engineering in MIT ADT University. He's working as a single point of contact for international collaboration between Indian education institutes and Aalborg University, Denmark. His research domain includes security and privacy. I welcome you, sir. Thank you so much for giving your consent to chair the session. Can we start with the paper presentations, if you permit?
Yeah, thank you, Madam Dr. Neha, for kind words, and I permit to begin with the session.
Thank you, sir. So the first paper presenter we have is from Indonesia, Randa Gustiawan. I'm sorry if I pronounce your name wrongly. He's going to present his paper titled Application of the JKN Mobile Application in Improving the Quality of Health Services During the COVID-19. I request you to start with your screen share, and you have to limit your presentation you are requested to strictly stick to the time limit of 10 minutes for your presentation. Thank you. The screen is visible. Kindly start with the slide share.
Slide.
Bring it to the full screen mode, please. You can press F5, the function key.
Can you hear my voice?
Yeah, we can absolutely hear you. Just start with your presentation.
Okay.
Kindly bring it in the full screen mode. I request you to press F5 to bring it in full screen mode.
Dino. Gimana?
Can you hear my voice?
Yes, we can hear you. Please start with your slideshow.
My name is Randa Gustiawan. I'm from Indonesia. I'm a master student of Government Science Muhammadiyah University, Yogyakarta. I will presentation about application of the JKN mobile application in improving the quality of health service during the COVID-19. Introduction.
Yes, we can hear you. Please sum it up within 10 minutes. Yeah.
What?
We can hear you clearly. Please continue with your presentation.
I repeat, introduction. COVID-19 has become a global pandemic after being announced by the World Health Organization on March 11, 2020. The pandemic first appeared in Wuhan City, China. Since it first appeared, many changes have occurred in the life of the world people, including in Indonesia. The government announced the first case of COVID-19 virus infection in Indonesia on March 2, 2020. The pandemic has a significant impact in health service. In addition, health service are focused burden with preventing transmission and handling cases of COVID-19, plus the implementation of the lockdown system. The COVID-19 pandemic has given important lesson in terms of bureaucratic governance in this COVID-19 era. The bureaucracy is obliged to maximize the use of technology, information, and communication in all matters in the government sector. Has an important role.
Please change your slide.
Literature review. Electronic government. E-government is a concept of a government system which in its governance implementation uses the latter information technology. According to Indrajit, e-government is the use of information technology by the government. They allow the government to transform relation with the community, and in its implementation, e-government uses the internet to carry out government affairs and public service, provide so that they are better oriented to community service. In measuring the extent to which e-government can have facility in providing competent service to help the community, it can be seen by using e-government indicator. namely ease of use, trust, reliability, content, and information display, and citizen support. Electronic service. The concept of e-service is a leading application by utilizing the use of information and communication technology. According to Rowley, electronic services are defined as action, effort, or performance whose delivery is measured by information technology. His electronic service include element of detailing service, customer support, and service. Research method. In this study, researchers focus on analyzing application of DJKN mobile application in improving service quality during the COVID-19 pandemic. The research uses qualitative research method descriptive data which taken from the JKN mobile application, Twitter with the hashtag mobile JKN online media, JKN website, and Play Store to support data from researcher who will implement the application of the mobile JKN application in improving the quality of health service during the COVID-19 pandemic. After that, some of the data collected was processed using the NPPO 12 plus software and then present descriptively in the observation finding of the mobile JKN application function. It will be seen its application in improving the quality of health service during the COVID-19 pandemic. Result and discussion. As of use. As of use, the JKN mobile application has made it easier for the public to access with the presence of several features, and this application can overcome the buildup of queues and prevent the spread of COVID-19.
I request you to sum up your work within last 2 minutes and kindly maintain the decorum of the platform. Thank you.
Okay. Lanjut. Conclusion, mobile JKN is a new innovation to improve service quality to the community, especially in the health sector, based on the analysis using a GovQual indicator which include as of use, trust, reliability, content, and information display, and citizen support. The JKN mobile application has been able to improve the quality of public service in the health sector during the COVID-19 pandemic. Thank you.
Thank you,
Thank you.
Gustivan.
So, okay, there are 2 requests from the participants that kindly stick to the time limit given to you, which is 10 minutes. Secondly, kindly keep your camera on during the presentation of your paper. We request you to turn your camera on while you're presenting the paper. Over to you, sir. Thank you.
Okay, thank you, Gustivan, for your presentation. Can you go to the first slide? Can you hear me?
There is a request to the presenter. Kindly go to the first slide of your presentation. I'm so sorry for the inconvenience, sir. I'm not sure if they can hear us because they're not responding to us at all. So if you permit, can we move to the next presentation?
Yeah, now he has turned on.
He's there on the camera. So Randa, will it be possible for you to move to the first slide of your presentation? The time limit given to him is over, sir. So if you permit,
I
can
think
we?
he is not able to connect with us. I
Right,
think we
right.
should go ahead. Yeah,
Thank you so
explain.
much, sir. All right. So with that, I now invite the next presenter, Surush Parsai from Canada. His paper is Flow Pattern Recognition Using Spectrogram of Flow Generated Sound with New Adaptive LBP Features. Kindly start with your presentation and screen share. Thank you.
So, okay, thank you. Can you see the presentation?
Yeah, we can see the screen.
Just let me know when you see the full window of my presentation.
We can.
Is it a full window?
Go
Thank
ahead.
you.
Thank you.
Hello, everyone. Warmest regards from Canada. I'm Surush Parsai, PhD candidate from the University of Windsor and working under supervision of Professor Majid Ahmadi. The topic of my presentation is flow pattern recognition using a spectrogram of flow-generated sound with the new adaptive local binary pattern feature. This is the outline of the presentation. We will go through a brief introduction of flow pattern and different identification methods. Then we will discuss the spectrogram analysis, LVP, and proposed method, and see the simulation results and conclude everything. Classifying the type of a two-phase flow is an important practice in different industries such as oil, gas, petrochemical, and food. This is especially helps the process control system to change the parameters to control the occurrence of them or sometimes prevent some unwanted damages that some of these patterns may create. Existence of a two-phase flow can cause different type of problems in our system, such as changing the heat transfer behavior, cavitation, and so on. But other than these, sometimes we need to know the type of the flow to determine the source of the problem that could exist within the system. In figure 1 in this slide, we can see some of the most common two-phase flow in two-phase flow maps in horizontal pipeline. When it comes to identifying these patterns, there are usually two main techniques in use. The first one is basically done by analyzing the parameters, in other words, finding the evidence of the existence of a particular type of flow from the parameters such as velocity and pressure change through the pipe. The second one more focused on the processing of the recorded sound of the flow. Understandably, the parameter analysis method is not automated technique and requires much more time for each instances. The second method, however, falls into two major techniques, putting the sound signal through the classification algorithms directly or analyzing the image representation of the flow sound spectrum via image processing techniques. Here in figure 2 in this slide, you can see a sample of the sound spectrum image. I'm sorry, due to its cost effectiveness, ease of implementation, and vast variation of the image processing techniques, analysis of the spectrogram of the flow sound as an image seems more convenient method. The fact that this identification is made by image processing creates numerous possible methods for classification of flows. However, according to the existing literature, flow characterization is facing some obstacles. Because these characterizations are dimensionally sensitive, they can only be used with the specific parameters of their research. So creating a universal flow pattern map for various liquids and pipe settings is a difficult undertaking. Local binary pattern, or LBP, is one of the most successful feature extractors, which extract texture features of the image by comparing each pixel with its neighbors. There is no training requirement, which makes it fast and easily integrable into the new data set. However, conventional local binary pattern algorithms use a fixed zero threshold. The LBP code is first run on all the pixels. A pixel's intensity is denoted by I, and dp here is the pixel difference for the pixel p. Illumination variation is an important factor that affects the pixel intensity changes of the standard images. Thus, the pixel difference also has a significant variation. It can be concluded from equation 1 that we saw on the previous slide. Only the sign of the pixel variation is used by the LBP, and the amplitude is being dismissed. The amplitude of the pixel difference contains meaningful data describing the spectrogram. Therefore, both the direction and the amplitude of the pixel variation are used in some research. When extracting the parameters from the spectrogram, in conventional LBP features, a fixed zero threshold, making it sensitive to noise. The noise can affect the system by changing the pattern bits for slight differences. One way to deal with this issue is to set the threshold of the pixel difference at f of I instead of thresholding at 0. We propose a new adaptive threshold function. This function is based on the local and global spectrogram information. This method does not make a different image blocks, but the proposed threshold changes it in each block. The proposed threshold function is based on the cumulative density function of Gaussian distribution function to have both fast and robust LBP features, as is shown in equation 18 and 19. We should note that the noise properties have a determining role in the formation of the threshold function. When image noise increases, the threshold value will be increased, and vice versa, leading to more robust LBP features. For the experimental setup, two hydrophones are used, and both of them are connected by an amplifier to a signal analysis workstation. The position of the hydrophones is shown in figure 4. The system's input is the signals with a frequency range of 0.1 to 10 kilohertz. The diameter of the pipe's upward side and downward side is 5 inches and 3 inches respectively. And figure 5 illustrates the schematic of the pipe with the position of two hydrophones. Here in this slide, we can see the results from comparing the flow pattern identification through spectrogram of recorded sound and signals with the proposed method and conventional local binary pattern. The proposed method is investigated for 4 flow patterns: stratified, crown, and annular, and slug. In the first experiments for the classification of pipeline flow, all the signals are sampled in 16 bits at 50 kilohertz using 2 hydrophones. The samples are collected from 4 classes of flow pattern types, consisting of 836 samples in total. The number of samples for each class is shown in table 1. In this experiment, 30% of samples are used for training, and added noise is same for training and test samples. As shown in table 2, the proposed method has 98.7% correct classification for clean samples, whereas the traditional LBP represents 96%, and the new method shows much better performance when noises are added. In the second experiment, classification on the RWCP database is conducted for further validation of the proposed method and comparing the results to 3 other methods. The RWCP database is an appropriate benchmark in validating the performance of the classification algorithms in many research. The database consists of crash sounds of plastic, wood, and other sounds like coins, bells, saw, and etc. The experiment is performed under 4 noise levels, 20, 10, 0, and -5 decibel using the noise EX92 database.
So you have last, okay, thank you so much for
Okay,
you're
finally,
right on track. Yeah, you're right there. Thank you. And please
okay.
keep your camera on. Turn your camera on. Thank you.
I have to quit from the full screen.
Oh, that's absolutely okay. You can conclude the slide and you can turn the camera on later on.
Okay.
Thank you.
So we proposed a new LBP feature based on a new cumulative density function of Gaussian distribution thresholding. The algorithm is an enhancement of the convolutional local binary pattern. A comparison is made between the new algorithm and 3 other feature extraction techniques. Our methods showed a better performance compared to conventional local binary pattern. Also, we got better results from our method compared to two of those other techniques. And although the third method showed slightly better results, the proposed technique excels in lower complexity and ease of implementation. And yeah, thank you. This is the end of my presentation.
Thank you so much, Sursh. You have completed it well on time. I now request attendees to come up with the queries if they have any. In case someone want to ask some questions. Okay, so can I request the session chair to start with the QA session? Thank you, sir.
Yeah, Sorush, thank you for your presentation. Can you just talk about the sampling method that you have used for your work? What type of sampling method being used?
Sampling method. So I use the recorded voice.
No, recorded voice of what?
The if we go back the experimental setup, I can show you the.
No, the voice basis, how you gathered those samples. Like number of samples you can hear, say 184, maybe the next slide where you have a table 184, 191, something you mentioned.
Oh,
yeah, correct. So 184, 260.
Sample of it's a 16 bits at 50 kilohertz voice recording of these types of flow in horizontal pipes.
So these are the voice recording samples, right?
Yeah, these are the number of recorded incidents of voice.
So recorded voices of how many people? How the people have been selected?
How the what?
How you select the people? Like how many people participated?
It's not for people. It's for the flow in the pipeline.
Okay.
Yeah, liquid flow in the pipeline.
Mm-hmm.
And since we knew the type of the flow that was flowing through the pipeline, so for instance, we simulate the stratified flow through a pipeline. Then we recorded 184 samples of that flow in 16 bits.
Okay, understood. Now, what are the features that you have considered? Can you just tell me the features, how the features are stored?
For the extraction features, I use the local binary pattern. So it's a technique that compares the pixel of an image and compare it with its neighbors to extract the features automatically. I didn't need to bold any features. The feature extraction technique is an automated system.
So how many features were extracted automatically?
So it depends on the resolution of your system, but the SVM features, the SVM classification that we used was different, and the number of features, I don't have them right now here.
Okay, fair enough. Fair enough. Thank you for your presentation.
Yeah, thank you. Thank you for your time.
Yeah.
Thank
Good
you
luck.
so much. With that, we move towards the third presentation, which will be given by Alexandra Chavez Gallardo from Peru. The title of the paper is Business Intelligence to Improve Decision Making in the Production Process. I request Alexandra to start with the screen share, and please
O-
keep your camera on while you're presenting the paper. Thank you.
Okay. Okay. Can you see my screen?
Yes, we can.
Okay. Hello, everyone. My name is Alexandra Chavez. I was working with two colleagues, Kevin Cabrera from North Private University and Michael Cabanillas. I'm going to present the paper, Business Intelligence to Improve Decision Making in the Production Process. This paper is structured in 6 parts. There are introduction, methodology, development, result, discussion, and conclusion. Introduction, business intelligence and the era of technology. During the last years, business intelligence has achieved positive results in different companies through the implementation of organizational policy areas.
We could hear
which-
you properly earlier, but not now. Kindly adjust your microphone. Thank you.
Can you hear me?
Yeah, we can.
Okay. Which contribute to improve business competitiveness. The era of technology brought many changes in the business environment. Therefore, the different companies must consider the development that has the technological tool business intelligence in the different processes. Business intelligence in companies. The problem faced by companies continuously arise due to the inability to analyze data. Therefore, it's necessary to apply business intelligence to evaluate and validate the data and obtain an appropriate strategy for the needs of different companies. Different organizations often store large amounts of data without having made a prior strategy on how to use it for optimal decision making. Decision making with what is business intelligence? Business intelligence is a technological tool that allows analyzing data and transforming it into available information to provide a result to the manager, planner, or decision maker in the company. The implementation of business intelligence deals with reducing errors and saving resources through decision making, providing information to the company in a detailed and reliable way. Decision making with business intelligence. The short period of time that decision makers have to make decisions depends on the access time to the information. For such reason, it's essential to reduce the execution time of the query by having a well-structured database to apply business intelligence. Now, methodology. We use Scrum. This methodology was selected because it includes several meetings and functions that support teams to structure and manage their work. One of the most important features of Scrum is its structure that serves to support the teams to adapt to changing conditions. Now, development. For the development of the system, we selected the Java language and the MySQL database. Also, for the architecture, we use the MVC pattern, separating the functions of the application in model, view, and controller, which facilitates its maintenance and scalability. Then, regarding business intelligence, we are using the data analysis service called Power BI, where first the user interacts with the dashboards, which is a graphical representation of the main metrics or KPIs. And this information that is being analyzed is extracted from the database. Now, let's talk about the sprint development work. In sprint number 1 was the development of production management. This sprint shows the interface of the technical data sheet, which once the finished product is selected and the type of input, service, and equipment is indicated, the technical data sheet is generated. Now, sprint number 2 is all about the storage management. In this sprint, the warehouse guide was developed, which records the incoming and outgoing quantity of inputs from the supplier. In sprint number 3, we implemented business intelligence. We made a graph by indicator. The first one is the productivity percentage. As we can see, we selected a pie chart, which is segmented by type of clothing. In addition, it can be filtered by year, month, and type of clothing. For the second indicator, which is the production time, we choose an array chart in which we place as x-axis the type of clothing and as y-axis the minutes. Finally, for the last indicator, which is the cost of inputs, we choose a group column chart. Now, in the development part, we can visualize this image that shows the algorithm we have used to measure the three indicators: productivity, production time, and input cost. For productivity, we are using the following formula. Productivity equals outputs divided by inputs. Then we compare the calculated productivity against the historical productivity. And depending on the value obtained, we qualify it in three ranges: low, equal, and high productivity. For the production time, we must multiply the number of machines by the number of hours in minutes and by the efficiency. Then, if the production time is greater than the historical time recorded, we qualify it as stagnation. Otherwise, if it's less than the historical time, we qualify it as successful production. And finally, for the input cost, we add up all dispenses in materials and hours work, and then compare them with the historical input cost and rate them if the cost increased, stayed the same, or decreased. Now, results. The research was carried out with the 30 production orders. The information collected was organized according to the indicators: number 1, productivity; number 2, production time; and number 3, input cost. Productivity. The figure shows that for the productivity indicator, the post-test control group and the post-test experimental group, P is greater than 0.05. Therefore, the productivity indicator has a normal behavior. Regarding the table using the Wilcoxon non-parametric test, it has a significance level of 0.000, which is lower than 0.005, which is the limit value for the acceptance of the research hypothesis. It's determining that business intelligence has a positive impact on productivity. Now, for production time, the figure shows that for the production time indicator, the post-test control group and the post-test experimental group, P is greater than 0.05. Therefore, the production time indicator has a normal behavior. With respect to the table, using the parametric test student test, there is a significance level of 0.000, which is less than 0.005, which is the limit value for the acceptance of the research hypothesis. It's determining that business intelligence has a positive impact on production time. And finally, for input cost, the figure shows that for the input cost indicator, the post-test control group and the post-test experimental group, P is greater than 0.05. Therefore, the input cost indicator has a normal behavior. With respect to the table using the parametric test student test, there is a significance level of 0.000, which is less than 0.005, which is the limit value for the acceptance of the research hypothesis. It's determined that business intelligence has a positive impact on input costs. Now, control group. According to the results shown in the figure, it shows the mean of the post-test and pre-test of the control groups for each indicator. Experimental group. According to the result shown in the figure, it shows the mean of the post-test and pre-test of the experimental group for each indicator. Discussion. For the three indicators, the pre-test means of the control and experimental groups are similar, which is evidence that both groups were in similar conditions before the experimentation. Regarding the productivity indicator in the post-test, the means of 1.4412 and 1.842 were obtained. This
Alexandra,
result show
you have last 2 minutes to conclude. Thank you.
This result showed that there was an increase of 30.5%. The results obtained coincide with the research of Paredes Atencio, in which he indicates that the business intelligence tool in the production process of an automotive company increased productivity by 20% once the tool was implemented. With respect to the production time indicator, in the post-test, average of 738.580 and 707.290 were obtained. This result showed that there was a reduction of 4.2%. The results obtained coincide with the research of Martinez Diaz Kevin, in which it's indicated that business intelligence in the textile company allows a better control of textile production activities once the tool is implemented. Regarding the indicator input cost in the post-test, it was obtained that the average should have a value of 70,361.450 and 70,292.10. This result showed that there was a reduction of 0.4%. The acquired results coincide with the research of Montanches Arturo and Manuel Zúñiga, in which it's indicated that business intelligence tool in the production process of a floor company increased production levels by 7.7% once the tool was implemented. And finally, conclusions. First, it's concluded that business intelligence technological tool has a positive impact on production time because it reduces production time, thus achieving the expected objective of the research. Also has a positive impact on productivity because it increased productivity, thus achieving the expected objective of the research. And finally, has a positive impact on input costs since it reduces the total cost of inputs, thus achieving the expected objective of the research. And that's all. Thank you for your attention.
Thank you, Alexandra. Over to you, Dr. Prashant. Because I don't think we have queries from anyone else. Thank you.
Thank you, Alexandra, for your presentation. I have a couple of questions. Sorry. So what is the improvement in decision making in the production process using the business intelligence that you have adopted? To what extent the decision making has been improved?
Well, we are using business intelligence to improve the decision making of production process. With business intelligence, you can create graphics of the metrics or KPIs, and with that, you can help the company to take better decisions, and you can have an advantage.
Okay, but there has to be some metrics, there has to be some comparison where you can say that decision making is improved. Any scientific justification for the decision making improvement?
Well, in my discussion, there are three research of three different authors that explain that applying business intelligence to companies actually increase productivity, reduction time of production, and reduce the input cost. So that is the scientific investigation of business intelligence applying to companies.
Okay. Second question is, are you targeting or have you thought of any particular business logic or any organization to implement your solution?
Yeah, we implement our solution in a textile company here in Peru. And about that investigation, that applying about that company, we get the results of this investigation, and the results are good, no? Because we increase productivity, reduce the cost of inputs, and reduce the time of production with these better decisions that give the business intelligence with the graphics and the metrics and KPIs.
Okay, thank you.
Thank you.
Thank you. I now invite the next paper presenter, Abhishek Deora from the US. The title of the paper is Efficient Net for Embedded Systems. Please start with your screen share. I'm sure he's there. Kindly turn your camera on.
Is my screen available?
Yeah,
Hello.
we can see that. Yes, yes.
And is my video and audio okay?
Yes, perfect. Thank you.
Right. So with your permission, I'll start. Cool. Hello, everyone. Welcome to the discussion of our work titled Efficient Net for Embedded Systems. I'm Abhishek Devkar, and I will be representing myself and Dr. Mohammed Al Sharkawi from the Purdue School of Engineering and Technology at IUPUI. This is the flow of what the presentation will look like. We'll go over all of these points. Convolutional neural networks, or CNNs, are pretty much the workhorses of computer vision domain, with applications in classification, object tracking, segmentation, etc. Transformers have recently been used in tasks of image classification, image segmentation, where the performance has been better than the state-of-the-art CNNs. Even so, CNNs continue to take advantage of improvements in hardware technology. One of the recent developments in CNN were the Efficient Nets, and a successor that quickly followed was the Efficient Net version 2, which achieved best performance on image classification tasks on ImageNet and other datasets. A lot is still desired for the deployment capability of such networks on embedded hardware, with objective of preserving the network performance while having minimal computational requirements. As with all the other embedded hardware-focused neural networks, our goal of designing this network was to reduce usage of computational resources. Let's take a look at the background our work is based on. Of course, that includes Efficient Net version 2. The table here describes the layers of the baseline architecture. We choose the baseline of our work as Efficient Net V2B0 because of its small size as compared to the larger Efficient Net models, which makes it useful for deployment on embedded hardware. We can observe the fundamental building blocks used in the Efficient Net architecture are the MBConv and the fused MBCon layers. Essentially, a slowdown was observed in the development of Efficient Net due to the use Efficient Net version 1 due to the use of depthwise convolutions. Depthwise convolutions have fewer parameters than regular convolutions, but they're not as effective or efficient in terms of hardware usage. Fused MBCon was proposed by Gupta and Tan in 2019 to better use accelerator hardware. It replaces the, and then in the design of their network, they replace the fused MBCon layers sequentially in the first couple of layers, as we've seen in the first few layers. This is another layer that that is been implemented in our work. This is called the sandglass layer. Sorry, I skipped a slide. This is another layer called the harmonious bottleneck. Harmonious bottleneck layer, HBONet was a network proposed by Duoli et al., in which they proposed harmonious bottlenecks. This was inspired by the design of the inverted residuals, or MBCon. Utilizing depthwise convolutions for compact network size, it takes advantage of orthogonal space size reduction by compressing the channel expansion contraction component into a pair of inverse spatial transformations. It has kept connections to from the first layer, before the first layer and after the last layer, to preserve more input information. This is the sandglass layer. This was also designed as an improvement over the inverted residual block. In a sense, it is a combination of a residual block and inverted residual block, and it takes advantages of both of their features. It is constructed such that the first and the last layers are the channel preserving spatial depthwise convolution layers with pointwise convolutions sandwiched in between them. That sequentially reduce the number of channels first and then increase them. This layer again utilizes skip connection to preserve input data. Recently, attention mechanisms have taken prominence with respect to transformers. This was done. This takes advantages from the channel attention methods, and this was implemented in the sandglass coordinate sandglass layers to together be called as the sandglass with coordinate attention. We construct the efficient next model in a manner similar to the baseline, where we keep the fused MBCon layer as the initial layers of our network. And instead of the inverted residual, we replace it with harmonious bottleneck layers. We make modifications to both these layers heuristically to achieve best performance. We also sandwich the fused MBCon layers and the harmonious bottleneck layers between the sandglass layers. This sandglass layers also were modified heuristically. The modifications we propose are the following. We replace the activations proposed in the fused MBCon and harmonious bottleneck layers with GELU. We reduce the kernel size in the harmonious bottleneck to 3x3 instead of the 5x5 in the original paper. This helps us in achieving a significant reduction in the number of parameters. We try a heterogeneous combination of activation functions in the layers used. The sandglass layers still keep the ReLU 6 from the original paper, whereas in our next work that is based on the harmonious bottlenecks and the efficient network works, we replace the SILU activation function with GELU, SILU or switch activation function with the GELU activation function. This combination was also again chosen heuristically for best results. The infrastructure for this research was provided by, supported in part by Lillian Endowment. These are the settings we utilize for training and evaluation of our network. We utilize the SGD optimizer and the other settings like momentum and everything. We keep a batch size of 128 and train the network for about 200 epochs. With the proposed modifications to the layers and additions, the training regimen improvements, we observe a slightly faster convergence with improved final accuracy and reduced number of parameters and model size. We were able to reduce the model size by about 56.25% while slightly increasing the accuracy from 90.76 in the original baseline to 92.13 in efficient next. We also performed width scaling experiments, and we observed that the proposed model that we designed called efficient next, when scaled down to 0.75 of its original width, was highlighted in red, outperforms unscaled baseline efficient net V2B0 by a slight margin, by a slight margin, achieving our goal of model size reduction, making it useful for deployment on embedded hardware with low compute capability. Our network scale to 1.5 times the width of the original reaches a model size still smaller than the baseline efficient net V2B0 with fewer parameters and improving accuracy even further. In conclusion, we introduced this network called the efficient next using a combination of multiple layer types adopted from harmonious bottleneck, efficient net, and sandglass or mobile next architecture. We achieve a stated goal of model metric improvement by changing parameters such that we obtain a reduction in model size and the number of parameters, a key consideration for deployment on embedded hardware, while improving or preserving the accuracy. Thank you.
Okay, thank you, Abhishek,
Thank
for your presentation. I have one question like which embedded system you considered to implement, like what type of hardware that being considered?
The goal of this network is to be deployed for object detection tasks on hardware from NXP. So consideration is ongoing for a hardware, but one of the candidates is the IMX8M Mini, something like that.
Any specific protocol you use?
For deployment, but I believe we'll be going with TensorFlow Lite for the actual deployment for test MS classification and other applications.
Okay, thank you. Now, best.
Thank you. Can I stop my
Thank
screen
you,
share?
sir. Thank you, Abhishek. Yeah. So we now move on to the next presentation. I call Nicole Romano from Romania. The title of the paper is A Comparison of Interpretable Machine Learning Models to Predict In-Hospital Mortality After Myocardial Infarction, analyzing 2 years data from a high-volume interventional center.
Hello, can you hear me?
Yeah, we can. Please start with your
I'm
screen share.
sharing my screen now. So do you see it?
Yeah, it's visible.
Okay. And it is full screen now, yes?
True. Yep.
Thank
Yes.
you. My name is Nikolai Romanov. I'm a PhD student at the Alexandru Ioan Cuza University of Iași, and together with my professors and colleagues from the Alexandru Ioan Cuza University and Grigore T. Popa University of Medicine and Pharmacy from Iași, we work together on the paper, and it is entitled A Comparison of Interpretable Machine Learning Models to Predicting Hospital Mortality After Myocardial Infarction, analyzing 2 years data from a high-volume interventional center. And I would like to start with the motivation of our research, and it is the fact that myocardial infarction, or MI, is the most common cause of death among patients with cardiovascular diseases. A significant percentage of MI cases is caused by ST segment elevation MI, and according to the latest European Society Cardiology guideline for the management of patients with STEMI, the primary percutaneous coronary intervention, or PCI, is the first-line treatment strategy compared to the pharmaceutical treatments. PCI reduces the mortality in acute STEMI patients by about 22%, but it's still, given the fact that it is proved some improvements in the prognosis of the patients, it still has a very high in-hospital mortality rate, which varies between 4 and 12% in different countries in different areas. That being said, identifying predictors for in-hospital mortality is an essential step towards MI prevention and consequent reduction in mortality. Aims of this research include providing a comparison between the accuracy of two machine learning models based on the 2 years data from a high volume interventional center serving the eastern part of Romania. And also we intended to identify predictors for in-hospital mortality, apply novel techniques for models interpretability to detect the predictive importance of the variables, and validate the models on an independent data set. This study was conducted with a hospital-based dataset, which contains information about 2,035 patients with information about such variables as age, gender, smoking status, left ventricular ejection fraction, diabetes, hypertension, dyslipidemia, chronic kidney disease, multivessel disease in 2 or more epicardial coronary arteries, those being the left anterior descending artery and the left main artery. Moving on, primary resuscitation, previous myocardial information, cardiogenic shock, instant thrombosis, and myocardial rupture. And of course, the outcome, the death. And speaking about the death, out of the total number of samples, 124 people died, which resulted in a 6.1 mortality rate. And speaking before, it is between those 4 to 12% that we spoke about. As for the methods and tools used, we chose random forest and XGBoost, which are widely used when working with the tabular data. And we use them because the main reason we use them is because they provide good and stable performance over different tasks in different machine learning areas. Given the fact that we have only 6.1% positive cases, we have to think of a way of treating the class imbalance data. And luckily, we have here random forest and XGBoost that provide built-in techniques for dealing with it. So we make use of those parameters, namely class weight for the random forest and scale positive weight for the XGBoost. Speaking about the parameters, we also perform the hyperparameter tuning using stratified cross-validation folds. And for the well, using hyperparameter tuning, according to some research, can lead up to 5 to 12 to 20% boost in performance. So for the random forest, we chose to optimize the number of estimators, the minimum sample split, the minimum sample sleeve, the max samples, max features, max depth, the criterion, and the class weight. And for the XGBoost, we chose to optimize the sum sample ratio, the mean child weight, the max depth, the gamma, the learning rate, and the booster. All of the combinations were trained using stratified case fold validation folds in order to avoid the overfitting problem. Okay. Besides obtaining a good model with a decent performance, we also are very interested in understanding why the model is giving those results. So we chose to present the two interpretability techniques at the model level and the instance level. Again, luckily, random forest and XGBoost present some built-in model level interpretations, that being the feature importances. And for the instance level interpretability techniques, we use the Python package Dalex, and namely two of those techniques, breakdown and breakdown interactions. Moving on to the results for the best hyperparameter options, out of the total number of samples that we, the total number of combinations that we can obtain from the hyperparameter tuning, we chose to loop over 1,000 random combinations. So we chose the random grid search, the random search or the grid search, and here are the results for the random forest and for XGBoost. One thing worth mentioning here is that all of the top combinations in the for the metrics have had the class weight balanced for the random forest and the sample positive weight of 15, which is the ratio of negative and positive samples. That being said, because it helps us to cope with the class imbalance problem. So the top values, the top metrics were presented by these values and not the normal ones. Moving on to the metrics, we obtained value of 0.9712 for Rocawook for random forest, and for XGBoost is a value of 0.9666, which is better than the logistic regression that was used in the original paper that was presented and what presented this data set. In the original paper, the Rocawook was of 0.933. We also outperformed the original logistic regression in terms of specificity in both models. So the original ones was 0.96, and we have here for random forest 0.977, and for XGBoost 0.991. But we encountered a problem in the sensitivity, which in my opinion is the most important metric of this all. And for the XGBoost, we had a lower value of 0.8 compared to the 0.84 in the original logistic regression, but we outperformed the original logistic regression with random forest with a value of 0.862. Moving on to the variable importances. On the left, you can see the variable importances for the random forest, and on the right for the XGBoost. You can clearly see that the top, I hope you can see that the top two variable for both models are the cardiogenic shock and the left ventricular ejection fraction, followed by the multivessel disease in the random forest, and followed by the hypertension in the top three for the XGBoost. The rest of the variables were equally important, almost equally important in the random forest and the XGBoost, with the exception of myocardial rupture that was apparently not very important in the XGBoost model. As for the instance level interpretations for the dialects package, we have the example of a breakdown plot in the left and the breakdown interactions plot in the right for an instance that has both predicted and true values equal to 1. So it was predicted that the person died, and in real life the person actually died. So we can see that a value for the cardiogenic shock, primary resuscitation, and multivessel disease of 1 contributed positively to the outcome, contributed positively to increasing the probability of predicting the one outcome. And on the right, we can see that one group formed by proximal lat and gender also increase the probability of predicting the outcome. One thing to say here, the idea behind the breakdown is to analyze the mean prediction of the model by subsequently changing all of the values of the features with the values from the analyzed instance. And the breakdown interactions here come in handy when the effects of some features depend on each other, and so we can create groups that can be interpreted together. As we can see here on the right, the proximal lat and the gender are grouped together because they.
Sorry to interrupt.
Okay,
you have 1 minute more to wind up. Right.
Yep. And the same thing is equal. It is the same thing for the misinterpreted instance, and the same thing goes for the XGBoost model for the true one predicted one instance and the true one and true zero and predicted one instance. Sorry. As conclusions, our paper brings novel proof for the efficacy of machine learning methods to predicting hospital mortality after PCI. It is the first research of this type using local data from our country. It is in line with the global effort to reduce mortality in MI patients through the use of modern computational techniques. And these results are essential steps in improving the current preventive strategies that lead to fewer deaths. Thank you very much. If you have any questions.
Thank you so much, Nikolai. I now request the session chair to take over. Professor Prashant.
What will be the improvement if we use deep learning?
Sorry?
What will be the improvement in your solution if we use deep learning instead of
actually, we thought of using some neural networks, but they do not go here very well because our data is tabular and we have only 2,000 instances, and it is not very much for a neural network to do because it will overfit very fast. So it is not. It was not used by us because it is not fit. It does not fit here.
Okay. Yeah, and you are predicting in hospital mortality. So
Yep.
any data that you received, how you approach to get the data, whether you took the data or you received the data?
We received the data from the high interventional center I spoke. I think I mentioned it here, but I did not mention it in text. So it is a high interventional center from the city of Iași in Romania, and it is responsible for the whole northeastern part of Romania in terms of cardiovascular problems of people. So we used the data from 2017 and 2019, if I'm not mistaken. So 2 years of data, and every patient that had some problems was the data about all these patients was recorded.
Okay, thank you very much. Yes,
thank you as well.
Thank you so much.
Thank
we
you.
now move to the last presentation of our session from Sonia Cadenas Delgado from Ecuador. I think she'll jointly present this paper with Paulette Parra. The title of the paper is Prototype Machine for Traditional and Technological Ophthalmic Tests Using Convergence Analysis. Over to you, Sonia. Thank you.
Thank you, Paulette. Thank you. Good afternoon, distinguished audience. We present our work entitled Prototype Machine for Traditional and Technology Ophthalmic Test Using Convergence Analysis. The authors are Sonia Cárdenas Delgado, Mauricio Lachamín Valencia, Paulette Parra Suárez, and Steven Taipicaña Cayambe. We from the University of the Armed Forces ESPE Ecuador. Next. The vision is one of the human sense that influence the way we perceive the world. The perception is of the most importance, as many military aviation maneuvers rely on accurate perception of distance. In this line, we developed two visual tests using virtual reality were implemented in our project. Both of these studies assessed the stereopsis and vision color through experimental studies using virtual reality. The results of both studies showed correlation with the traditional test. However, to improve the accuracy of the results of the assessing, next, we proposed to build an ophthalmic testing machine that allows traditional and technological tests to be integrated to improve the assessment of pilot candidates' visual abilities. Computer-based testing need to be applied. This machine includes a mechanical body support, facial support, car support, and visual test. Next. Methods. Also, it is true there are several ways to develop a product depending on the application or the sector to which said product is directed. This work uses a general product development process detailed by Ulrich. This process is made up of the following steps that will be described below. Planning include idea of the product, concept development is comply with the requirements, system level design, define the components and subsystem in the phase, detail design. The main system is decomposed into two subsystems corresponding. And finally, testing and refinement phase completes evaluation before reaching a final prototype. Now, continue, Paulette. Thank you.
So now I'm going to explain to you the concept development. First, of course, we needed to know the requirements that the people that is going to use this machine needed. So we asked the doctors and the people in charge of performing the ophthalmic test what they needed in order to perform all the tests in one single machine. We found 5 requirements, main requirements that are easy assembly and disassembly, low cost, take up little space, being comfortable, and all configurable for the different type of tests that they perform. All these requirements were translated to characteristics and engineering parameters that you can see in the table. Then, of course, we needed to do the product outline, in which, well, we tried to sketch all the parts and components that we needed. For example, we needed obviously a chair and a table for the patient support, and we needed the facial support since we need to keep the gaze of the patient in one spot for some tests, and the card support for the traditional tests that usually need this kind of support in order to perform the test. Of course, this needed to move, so we implemented a way, or we tried to think in a way of moving the card support in all the 3 axes. And of course, driver, software, and user interface for the people that is going to use the machine. Then in the next stage of the methodology, we have the system level design, in which we put the main things that we thought that could solve the problems that were presented to us in the requirements. For example, the design of the chair must be adapted for the user's comfort, because the user is the most important stakeholder in this kind of study. Then we have that the structure needs to have bases for monitors, because some of the tests does not require card support, but they need like monitors because they use computers or brain sensors, etc. The facial support must be removable, since not all the tests require them. The design must be ergonomic, and as I said, we needed to move also the card support, so we tried to implement a CNC movement, kind of movement. And we implemented in software like Raspberry Pi, and in order to control the things that we needed to control. For the detailed design, we did the mechanical component. We designed the 3 main things that we needed, that were the face support, the motion system, and the card support. And in the face support, we have like the forehead support and the jaw support. Being the jaw support, the most important part of this the mechanical component, because it's the one that holds the most weight from the face, and the motion system and the card support, because they also need to be really resistant in order to be a good prototype. Finally, for the testing and refinement, we use the converge analysis, since we know that before doing any kind of analysis of the resistance, we needed to find a way in which we can achieve accurate results while balancing size and solving time of our model. That's why we implemented first the converge analysis before static analysis, since the mesh convergence determines how many elements are required in a model to ensure that the results of the analysis are not affected by changing the size of the mesh. So you can see the results of the graph of one of the analysis that we made from the mesh. We use like default element sizes that we can find in like real life, and the strain error is really, really low, is 1.96%. And for the other systems that are like critical systems, for example, the facial support, the motion support, and the card support, and you can see the components that we analyze, the strain error is between 2% and 1%. So the mesh is really, really accurate, and we can perform the static analysis. For the static analysis, we use like the software that the software finite element analysis, and we had like security factors that were really, really high, so we can now say that our prototype is going to be really resistant in the main parts that need to be resistant, like the jaw support, the rear support, and the edge liner guide. You can see there the material and the strength that the material that we use, and obviously the security factor. So finally, As conclusions, we applied the general product development process and we designed this ophthalmic testing machine that will allow pilot candidates to be evaluated, since, as we said in the introduction, it's really important to know if they have all the vision abilities that they need in order to perform maneuvers in the air. Then we have implemented 5 systems for this product screen: the chair, the table, the face support, the card holder, and software control. And all of them were analyzed with the converge analysis and using the standard norms for the things that needed to be ergonomic, etc. We implemented this adaptive mesh refinement by convergence using the H method. That is one of the methods that is possible to use for this kind of analysis. And finally, we think that this machine could improve the accuracy of the results of each test, because now we can allow the assessment. We will allow the assessment the participants in one only machine in a single place. That reduces the time, that reduces the comfortability of the participants or the pilot candidates that are going to take this test. And that will be all. Thank you for your attention. I don't know if you have any questions.
Thank you so much, Sonia and Paulette. That was a very interesting presentation, joint presentation, I would say. May I request Professor Prashant to come up with the queries? I request Dr. Prashant to bring up the QA session. I'm sure he'll shortly join us back. He's right here. I request Professor Prashant Dhotre to start with the Q&A session. I think there is some kind of technical limitation because of which we're unable to hear or even see him, because he's very much there, connected with all of us in the meeting. Just give me a moment to get back to you. So in the meantime, Professor Prashant joins us. I would like to ask one question to you, Sonia. So how long has it been for you to to come up with the idea and the implementation part of your research work? How long has it been for you to? Can you hear me, Sonia? Are you there? Yeah.
Yes. Yeah.
So how long the research work is? When did you start it?
My team is approximately 20 months in this design and model about the machine. Now we have a prototype machine, and our project is currently being developed. The goal is to improve the assessment of pilot candidates' visual abilities. Is very important for our country and Army forces.
All right, thank you so much. Paulette, can you just tell us how your work would contribute to your society? Do you think some similar work are already going on, right? So how your work is different from them and how the work can be a contribution to the society? What difference will it make? What do you think?
I think the main difference is that we are trying to implement this machine in a not so investigated field, that is the aviation field. And since we are in a university that is part of the armed forces of our country. We need to help them to improve the technology that they use. And see, I know that there are other technologies similar to ours, but here in Ecuador, there is no other technology, and we still keep doing traditional tests in the way that it's traditional, and it's not accurate and does not have a good efficiency. So we wanted this test to be like comfortable for the patient, but also help the medical professionals do the test in an easier way, in a more efficient way, and also to have accurate results, since there are a lot of accidents that are caused because of the lack of certain visual abilities.
So I wish all the luck to Sonia and Paulette for your work. With that, I would like to conclude today's session. We hope the session chair will be able to join us back in a moment. In the meantime, I would like to sincerely thank the authors for their excellent presentations in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 5 to 6 months. Kindly cooperate with the team of ICICT 2022. Professor Prashant hasn't been able to join in because of some technical issues. Even though he's not here, I would like to extend my thanks to him for chairing the session. Thank you all for your valuable presence. I would also like to flash a certificate of appreciation to Professor Prashant Dhotre, who successfully and interestingly conducted the role of session chair for the session. I would now like you to, I would request you all to turn on your cameras for a moment so that we can have a quick snapshot of this virtual meeting, this virtual conference. Let's turn your cameras on for a while so that we can have a snapshot and capture the moment together. Can I have those vibrant smiles on your faces? Thank you so much, everyone. Keep smiling, stay safe, take care.
Thank you so much.
Bye for now. Pleasure. Take
Bye.
care all.
Thank you.
Yep.
Thank you.
Thank you.
Thank you.
Thank you.
We are now ending the session. Thanks once again.